In class, we saw what happens when we interact two dummy variables and what happens when we interact a dummy variable and a quantitative variable. In this video, I show what happens when we interact two quantitative variables. So suppose we have a regression where we regress a salary or wage on years of education, age, and then an interaction between education and age. How does that change the interpretation of beta 1 and beta 2 coefficients? And what is the interpretation of the beta 3 coefficients? So let's see if we can write down some conditional expected values. So I'm going to see if I can write down the expected wage given that I have education I plus 1 and age equals 21. So what is the expected wage of someone who's got education edu I plus 1 and is 21 years old? What is that in terms of the betas? Well, it will be beta 0 plus beta 1 times edui plus 1 plus beta 2 times, what's age? Age is 21, plus beta 3 times, and now we have edu I plus 1 times age, which is 21. All right, how about expected wage of someone who's got education just edui, not plus 1, and is still only 21 years old. What is that equal to in terms of the betas? Well, it's beta 0 plus beta 1 times edu I plus beta 2 times 21 plus beta 3 times edu I times 21. What is the difference between these two conditional expected values? Well, let's write it out. Expected wage given that edu I plus 1, age equals 21, minus expected wage given that we have just edu I and the same age. Age equals 21. So the difference between these two conditional expected values, let's say, so if we subtract this one, the bottom one from the top one, we know that this cancels out. Certainly, this cancels out. This cancels out. This cancels out. And we're left with, and I'll go back to my red, with just beta 1 plus beta 3 times 21. So the effect of an additional year of education for a 21-year-old is beta 1 plus beta 3 times 21. Let's see what that is when we actually estimate the betas. And I asked that right here. What is the effect of education on wages of a 21-year-old person? That's beta 1 plus beta 3 times 21. So our estimates, here we have beta 0. This is our beta 1, beta 2, and beta 3, the coefficient on the interaction. So beta 1, the coefficient on education, is 3,887 plus beta 3 is 52 times 21. So 52 comes as the coefficient, beta 3, and 21 is that's the effect of an extra year of education for a 21-year-old. So making this calculation gives us 4,979. So an extra year of education for a 21-year-old boosts his or her wages by about 5,000. What is the effect of education for a 60-year-old? Well, we could write out, again, all of these conditional and expected values, but it would boil down to the following. Here is expected wage, given that I have EDUI plus 1, and given that age equals 60, minus expected wage, given that I just have education EDUI and my age is 60. That would be equal to beta 1 plus beta 3 times 60. Using our estimate, that would give us 3,887, which is beta 1, plus 52 times 60, which gives us 7,007 dollars. So an extra year of education for a 60-year-old gives him or her a boost of $7,000. So what is this telling us? If we interact two quantitative variables, it allows us to account for the fact that the effect of a one quantitative variable may differ with the value of some other quantitative variable. In this case, the effect of education is different when you are 21 years old, and then when you are a 60-year-old. Right? If I compare two 21-year-olds and they have different levels of education, the difference is not as big as when I compare two 60-year-olds and they have different levels of education. In other words, the benefits of education actually get bigger as you get older. And we can certainly illustrate that with these last two questions. We can ask, well, what is the expected wage, given that EDU equals, well, college graduate, let's say that's 16 years of education, and age equals 21, minus expected wage, given that education for high school graduate, that would be, say, 12 years of education, and age is still 21. We can plug in 16 for education and 21 for age into this equation and calculate what's the expected wage. From that, we can subtract expected wage given different values of education and age. But we can also do it perhaps more easily by seeing that, well, an extra year of education for a 21 years old gives a boost of 4,979. So 4 years of education would give us a boost 4 times that, and that brings us to 19,000. I believe this is 946, right? About 20,000. So the difference between expected wages of a 60-year-old college graduate and a 60-year-old high school graduate, I won't write it all out, but you can certainly do this at home. That difference is going to be bigger than 20,000. It's going to be 4 times 7,000, which is roughly 28,028. So again, we see that the differences between people with more or less education go wider. The gap gets wider as people get older. And that's what we get when we interact two quantitative variables.